Hey everyone, how it's going? This is Harish Dalal and welcome to our channel CodeChef. So the problem today I will be taking is SMALLSQ square. It is an easy medium problem from practice section. The code for which is SMALLSQ. The prerequisites are prime factorization and sieve of Eratosthenes. So before we get actually started, here is a reminder to hit the subscribe button if you haven't yet already. So this is the problem definition. La Sessica was a French maid who was a specialist in cleaning utensils. La Sessica was very efficient if the number of utensils left to clean was a square number. Her master gave her n utensils to wash. Due to her skills, Sessica had gained power to multiply utensils by one another. That is, she could multiply 5 utensils by 2 utensils and produce 10 utensils. What is the smallest positive number of utensils by which Sessica must multiply the n utensils given by her master so that she can efficiently clean them? So for example, let's say the given number is 2 and n is 2. So we have to find the smallest number to multiply to n to make it a square, perfect square. So here the minimum number we can multiply to 2 is 2, which will make it 4 by multiplying to 2. So 2 is the smallest number in this case. If n is equals to 4, in that case we just have to multiply it by 1 because 4 is already a perfect square. Hence 4 multiplied by 1, it will give us 4. So 1 is the smallest number we need for 4. If n is equals to 12, then in this case we will require 3, because 12 times 3 will give us 36, which is the perfect square and which we can get by multiplying it by the smallest number 3. So hence we have to find a smallest number by which multiplying the n we will get a perfect square. The given constraints here are the test cases could be 1 million, which is 1e6, as well as the n can be 1 million, which is 1e6. So we have to find an efficient approach to find the smallest number. Let's go to the approach one by one, starting with the brute force approach. So let's say we have given n. Now the minimum number we can be in the range of n plus 1 to n times n, because this is also a square, n times n is also a square. So we just have to iterate over n plus 1 till n times n, and after multiplying to every number in this range we will check whether that number is a perfect square or not. But this approach will be brute force approach and it will give you TLE. Let's start with the observation. Let's say we have the number 12. What are the prime factors of 12? So it will be 2 times 3. So how does the number becomes a perfect square? In that case, for a number to be a perfect square, each prime factor of it should be in even numbers or has a even power. In this case, 12 has 3 prime factors. 12 has 2 prime factors, where 2 is occurring 2 times and 3 is occurring only 1 times. It can also be written like 2 power 2 multiplied by 3 power 1. Hence due to this we don't have any problem with 2 because it is having even number of power. But the issue is with the 3. 3 is having just 1, which is odd. Hence we need one more 3 to make 3's power even. Hence it will be 2 power 2 times 3 power 2. Now every prime factor is having even power. Now this number is a perfect square, because this is obvious. If you square root this number, the even powers will be divided by 2 and the square root will become 2 times 3. Let's take another example. Let's take a perfect square itself. Let's say we have 36. So the prime factorization of 36 will be 2 times 2 times 3 times 3. Here the powers are in even numbers. The powers of each prime factors is in even number, which is 2 power 2 and 3 power 2. can see both are even, hence this is a perfect square, we know, and we have to multiply only 1 to it to make it a perfect square. So the conclusion here is we have to find the prime factors of the given number, and whichever prime factors power is odd, we have to multiply that prime factor to make the power even. Hence this will be the most smallest number required to make that number a perfect square. So how does we calculate the prime factors of a given number? Let's say we have to find the prime factors of number n. So what we will be doing is we will be computing SPF, which is the smallest prime factor of every number. So SPF of I denotes the smallest prime factor of I. Like for 12, the smallest prime factor of 12 is 2. So we will be calculating this. So the procedure to calculate prime factors of n with the help of SPF is we have to divide n with the SPF of n until our n becomes 1. So it will be like, while our n is not equals to 1, we will store our prime factor in a map or dictionary, whichever language you are using. So it will be map of int and int, and for the prime will be SPF of n and MP of prime plus plus. We are incrementing the frequency of that prime, and we are dividing n with the prime. So this is the method of calculating prime. So the complexity of this particular routine is just log of n, and calculating SPF we will calculating it with the help of sieve, and we will pre-compute it before running over all the test case. So it will take n log of n. So the time complexity for each test case will be just log of n, as the time complexity of our test cases will be t log of n, and which is sufficient, which will pass our test case. So let's move to the C++ code now to understand it better. So first of all, I'm taking the t test cases, and after that I'm creating SPF vector of size 10 power 6 plus 1 and initializing it with 0. I'm passing that vector to the function sieve. So my sieve pre-calculates all the smallest prime factors for I. So I am running a loop from 2 to 10 power 6 plus 1, and if my SPF of I is 0, it means that this particular number is a prime, and we have to initialize the SPF. The smallest prime factor of a prime will be the prime itself, and after that I'm running a loop from I times I till 10 power 6 plus 1 and updating the multiples of that prime to the prime. The SPF of the multiples of that prime will be the prime. After performing the sieve, I am running the test cases. For each test case, I am taking the input n and creating a map to store the frequency of each prime factor coming in n. As I said, I will run this loop until n is not equals to 1, and MP of SPF n, this particular is the prime factor of n. I am incrementing it by 1 and dividing the n with the SPF of n. After that, I am initializing an answer equals to 1, which will be the final answer. I am iterating over my map and checking whether the frequency of that particular prime, if it is odd, then I am multiplying that prime to my answer, because we have to make that prime even. And finally, I am printing out the answer. One thing to consider here is we have to write this fast IO so that we don't waste a lot of time on printing our answer, hence it might give us TLE if we don't use fast IO in this particular problem. So make sure to use this. Let me submit this C++ code. So yeah, we got a correct answer for C++. Let's move to the Python code now. So for Python, I've created this C function as well, and I'm running the loop for 2 to the 10 power 6, and if SPF of I is equals to 0 initially, that means that is a prime, and I'm initializing it with the I itself, SPF of I equals to I, and then running the loop for all of its multiple starting from I times I till 10 power 6, and if the multiples SPF is 0 right now, then I am initializing it with the current prime, and I'm running this save function now before the test case. Now I'm taking the test case as the input and running the for loop for this test case. For each test case, I'm taking the input n and creating a dictionary MP. I'm running this loop until my n is not equals to 1. I'm taking a variable prime, which is the SPF of n, which is the smallest prime factor of n. If prime is already present in MP, then I'm incrementing it, else I am initializing it with 1, and I'm dividing n with the prime. I'm using integer division here. I'm creating the answer equals to 1, and I'm iterating over the map with the key values in map.items. If value is odd here, I'm multiplying the key with the answer, and finally I'm printing the answer. Let's submit this Python code. So yeah, it's all correct. Now let's see some of the common mistakes that you can avoid. We have to run this save function before going inside our test cases for loop. We don't have to pre-compute save for every test case as it will give us TLE. Make sure to use the fast IO, else you will get TLE in C++ code. Let's go to the Python code now. Here the same thing, don't run this function inside the test cases, run it, we have to pre-compute it. And again, one thing, we are using the integer division here with n. That's it from my side. Hope you liked the video and got the concept. If you're interested in competitive programming and want to learn and master data structures and algorithms, subscribe to our channel and press the notification bell. You can also stay updated via our Telegram group. The link is given in the description. If you got any doubt, let me know in the comment section. I'll see you in the next one.